coming to mutual inductance. So we already have learnt about self-inductance and we have learnt about inductors. Now suppose in inductor we have seen that either if there is a solenoid or if there is a coil, and if the current changes, then due to the change of current the magnetic flux changes, and due to change of magnetic flux the induced EMF also changes, and that's what we have learned. Now in mutual inductance what happens, the induced current or the current that is induced, it is due to a certain change of current of another coil. Means what? In this case there are, suppose, two coils, right? And these two coils, one is called primary coil, another one is called secondary coil. Now if in the primary coil the current changes, then therefore due to this change of current the magnetic flux would change, and due to the change of magnetic flux in the secondary coil there would be induced current. So EMF is induced here due to the change of current here. So in the primary coil if I have a change of current, then in the secondary coil there would be induced current produced. This phenomena is called the mutual inductance. So in self-inductance we have seen that there is only one coil and due to the change of the current in the circuit the coil produces an EMF. And here there are two coils, one is primary, one is secondary. Due to the primary coil current change there is an induced current in the secondary coil, and previously due to one coil the production of EMF we have called it as self-inductance, and here since there are two coils and there is EMF production due to this mutual coils, so we call it as mutual inductance. So this phenomena is called as mutual inductance. Now suppose for my first coil, suppose that the magnetic flux, the current is moving here as I1, and due to here for this primary coil, let's suppose the magnetic flux change is phi1. Due to a magnetic flux change I have something called magnetic field B1, and in the secondary coil I have magnetic flux change phi2, and the field is B2. So right now we are not talking about B1, B2 or the magnetic field in these two. So we will more concentrate on the magnetic flux in this one. So magnetic flux is M into I1. So this M is the mutual inductance I in mutual inductance in primary coil due to the secondary coil, and here the mutual inductance is M21 in secondary coil due to the primary coil. This is I2. So this is very similar concept that we have seen in self-inductance, where we have told that this magnetic flux is proportional to I, or the flux change is proportional to the current, and that is what here we are seeing. The magnetic flux change is proportional to the current, but their proportionality constants, this constants we are calling it as mutual inductance. So this is mutual inductance in primary coil due to the secondary coil. This is the mutual inductance in the secondary coil due to the primary coil. And generally it's been seen that M12 is very much equal to M21. That we will prove taking two solenoids or taking two coils. We will prove that. But this is what happens. So generally both the mutual inductance for this couple primary and secondary coils, their mutual inductance is same. So in that case, we also for Faraday's law, going ahead, we can also say that the EMF produced according to Faraday's law is d phi by dt. So we just write d dt of M12 I1, or in this case we can write this is d dt of M21 I2, right? So this is the formula for the EMF produced in this primary and the secondary coil. So from here we can define that, suppose if this EMF is 1 volt, if di2 by dt, or the rate of change of current is 1 ampere per second, then the mutual inductance would be 1 Henry. Same way, for 1 volt of EMF and di1 by dt is 1 ampere per second, then therefore mutual inductance will be 1 Henry. So in this way also we can define that 1 Henry would be the mutual inductance if for a change of 1 ampere per second, suppose in primary coil my current changes 1 ampere per second and the EMF produced here is 1 volt in the secondary coil, then we can say that the mutual inductance is for this is 1 Henry. If di1 by dt is 1 ampere per second and here the EMF produced is 1 volt, then we can say that the mutual inductance is 1 Henry. As we have told that in the mutual inductance for phi 1 it will be mu1 M1 of 2 in primary coil due to the secondary coil. There is one thing that we need to keep in mind. For the flux in the primary coil is due to the current in the secondary coil, whereas the flux in the secondary coil will be due to the current in the primary coil. So according to in general my flux is m into phi m into the I, this doesn't change, but when we in detail, when we talk about two coil and we try to understand this thing, then remember that the phi 1 the flux in the first coil is due to the current in the second coil, and the flux in the second coil is due to the current in the first coil. And according to same way we can just see this is a little change. So this will be M1 to I2, and same way this will be minus d dt M21 I1. So this will be the for the flux EMF for the flux phi 2, and this will be EMF for the flux phi 1.
If you like the video, then press the like button, subscribe to the channel and press the bell icon.